take this question. It says two bodies X and Y of masses 5.0 kg and 7.5 kg respectively are connected by a light inextensible spring as illustrated in the diagram above. If X is placed on a rough surface of coefficient of friction 0.5, calculate the magnitude of the I, normal reaction on X, II, frictional force between X and the surface, III, tension in the string. So, solution, we have to do that quickly. Now we have to calculate, the I says we should calculate the normal reaction, R. Now normal reaction is the force that opposes the weight of a body placed on a surface. So this 5.0 kg mass is placed on this surface. The weight acts vertically downward, W, and the formula for weight is what? Mass of that body times acceleration due to gravity. So since this weight is not sinking the ground or is not creating any counter force, or it's not pressuring the ground that much to affect it, that means there is another force that is acting upward called reaction force, R, that balances it, that keeps it stable there, not to offset the ground. So since it is in equilibrium position, that means R equals to the weight. So R equals to what? Weight. And weight equals to what? Mass times acceleration due to gravity. And the mass of that body is 5.0 kg, so which is the same thing as saying 5 times. Acceleration due to gravity is 10. So you now have what? 50 Newton. So the normal reaction on X, on that mass, is what? 50 Newton. The second question says frictional force between X and the surface. So that's II. Frictional force. Now for a body placed on a horizontal plane, frictional force F is given by what? Coefficient of friction mu times the normal reaction R. So this equals to what? Coefficient of friction from the equation is 0.5. The coefficient of friction measures how rough a surface is. So the higher the coefficient of friction, the rougher, or should I say the rougher or the more rough the surface is. So for a perfectly smooth surface, the coefficient of friction is 0. Take note of that. So this is times normal reaction, which is 50. Which is 50. So 0.5, which is like a half, times 50 will give you 25 Newton. So question number 3. This is the kind of question we call question with babies. Question number 3, tension in the string. So this one is a bit practical. So you listen, you see how I'm doing it. Tension is created when there are two opposite forces acting on a wire or string or on a material. So you see there is a string here, and we have been told it's inextensible. Good, because if it happens to be inextensible, that means it will absorb some of the force, or it will absorb or add some forces. So since it's inextensible, it has no effect, and since the pulley here is smooth, that means it also have no effect on the resolution of the forces here. So tension is created because Y is trying to draw this rope to the right towards the down, while X is trying to draw it to the left, try to keep it on the left side. So tension is now created on this string. So we have to calculate what the tension, that tension T in the string. So if we assume that Y is heavier than X, that's if we assume that the whole system will tend to move to the right, our equation will become, if it tends to move to the right, that means the tension on the string is more than the frictional force. It's more than the frictional force on X. The tension on the spring is more than the frictional force of F. That we assume that the system will go towards the right. So in that case, we write that T there, T minus the frictional force F will give us what? The resultant force. And the resultant force is given by mass times what? Acceleration. This acceleration A represents the common acceleration that the system will move with. So our T, we don't know, that will be T minus our F is 25 Newton. We already calculated it, 0.5 times 50. So we write here 25 equals to our mass of X is 5. 5A. 5 times A. So I'll label this as our equation 1. The reason I keep it as equation 1 is there are two unknowns in this equation, and when there are two unknowns in equation, you can't determine any of them unless there are other equations that you use to support it. T here is unknown, A is unknown, so you can't determine any of it. So now we consider the second mass here, Y. Now since we assume that the system will move towards the right, though we are not sure, because after calculation we will know which one we will know where the system will tend to move towards don't mind my English, sorry. So we go to that of Y. Now since we said the system is trying to move towards the right, that means the weight of Y is greater than the tension. So in that case, that will be the weight of Y minus the tension will give us what? The mass of Y times the acceleration. And the weight of Y is given by 7.5 times 10. You know, that's the 7.5 there is the kg multiplied with acceleration due to gravity will give you the weight. Then minus the tension, which we don't know. Then mass is 7.5 times acceleration. So this become our equation 2. So we shift this thing upward so that we keep solving. So what is left now is to solve this simultaneous equation. The simultaneous equation, the first equation is T minus 25 equals to 5A. Now the second equation, 7.5 times 10 is 75. 75 minus T equals to what? 7.5A. So if you rearrange the second equation so that T will take the first position, so you have that minus T, plus 75 will give us 7.5A. So this is our equation 1. Equation 1 and our equation 2. So solving this simultaneous equation using elimination method, you see here T is positive, here T is negative. So if you add both of them and their coefficient there is +1 and -1, so if you add them, they will cancel and it becomes 0. So if you do equation 1, that's elimination method, equation 1 plus equation 2, T plus minus T, which is T minus T, will give us 0. So T is gone. Minus 25 plus 75 will give us 50 equals to 5A plus 7.5A will give us 12.5A. So if you divide both sides by 12.5 in order to make A the subject of the formula, you have that A will be equals to A will be equals to 4 meter per second squared. So now, since this acceleration is a positive value, that means our assumption was right. The system will tend to move towards Y towards that means y is the mass having the greater force or creating the greater tension or the greater force. So, but we were not told to find the acceleration, assuming we were told to find that is what it would have been. So, for us to now find our t, we have to substitute the value of a in any of the equation, whether equation 1 or equation 2. Me, I'll substitute it in equation 1. So, if you substitute a equals to 4 in equation 1, you have that t equals to, you have that, let me, you have that t minus 25 equals to 5 times a, which is 5 times 4. 5 times 4. So, let me continue. This will now be t equals to 5 times 4 is 20. And if minus 25 moves to this side, it becomes plus 25. Becomes plus 25. So, and if you add that, that will give you 45. 45 Newton. So the tension in this string is 45 Newton. Now, someone will say, what if we have assumed that the system will move towards x? Yes, if we had assumed that the system will move towards x and follow the calculations accordingly, for this first equation, that it would have been 25 minus t equals to what? 5a. And then the second equation would have been t minus w equals to 7.5a. If by the time you finish calculating, your acceleration would be minus 4. It won't be plus 4, it will be minus 4. And when you substitute to get t, your t will still be 45 Newton. So mathematics means universal truth. Anywhere you flow, any direction you take it from, you still arrive at the same point, which is the truth. So subscribe to the channel as is a form of encouragement. And then for online classes, you can join my WhatsApp group. Yeah, the link is in the description. Join my WhatsApp group, and then we discuss and then see how to carry on the real-time classes. Thank you.